Before start this video, please subscribe my channel and click on bell icon. Thanks.
V1674 Herculis is a classical nova hosted by a white dwarf and dwarf companion and is currently the fastest classical nova on record. While studying V1674 Her with the VLBA, Montana Williams, a graduate student at New Mexico Tech who is leading the investigation into the VLBA properties of this nova, confirmed the unexpected, non-thermal emission coming from it. This data is important because it tells Williams and her collaborators a lot about what's happening in the system. What the team has found is anything but the simple heat-induced explosions scientists previously expected from classical novae. Classical novae have historically been considered simple explosions, emitting mostly thermal energy, said Williams. However, based on recent observations with the Fermi Large Area Telescope, this simple model is not entirely correct. Instead, it seems they're a bit more complicated. Using the VLBA, we were able to get a very detailed picture of one of the main complications, the non-thermal emission. Very long baseline interferometry, VLBA, detections of classical novae with dwarf companions like V1674 Her are rare. They're so rare, in fact, that this same type of detection, with resolved radio synchrotron components, has been reported just one other time to date. That's partly because of the assumed nature of classical novae. VLBI detections of novae are only recently becoming possible because of improvements to VLBI techniques, most notably the sensitivity of the instruments and the increasing bandwidth or the amount of frequencies we can record at a given time, said Williams. Additionally, because of the previous theory of classical novae, they weren't thought to be ideal targets for VLBI studies. We now know this isn't true because of multi-wavelength observations which indicate a more complex scenario. That rarity makes the team's new observations an important step in understanding the hidden lives of classical novae and what ultimately leads to their explosive behavior. By studying images from the VLBA and comparing them to other observations from the Very Large Array, VLA, Fermi LAT, New Star, and NASA Swift, we can determine what might be the cause of the emission and also make adjustments to the previous simple model, said Williams. Right now, we're trying to determine if the non-thermal energy is coming from clumps of gas running into other clumped gas which produces shocks, or something else. Because Fermi LAT and New Star observations had already indicated that there might be non-thermal emission coming from V1674 Her, that it was also more interesting, or cute, as Williams puts it, because of its hyperfast evolution, and because, unlike supernovae, the host system isn't destroyed during that evolution, but rather, remains almost completely intact and unchanged after the explosion. Many astronomical sources don't change much over the course of a year or even 100 years. But this nova got 10,000 times brighter in a single day, then faded back to its normal state in just about 100 days, she said. Because the host systems of classical novae remain intact, they can be recurrent, which means we might see this one erupt, or cutely explode, again and again, giving us more opportunities to understand why and how it does. The National Radio Astronomy Observatory, NRAO, is a major facility of the. Thanks for watching. Please subscribe my channel for more videos.